All right, folks, looks like we're good to go. Hang on, let me just check the lighting. All right, I think we're good to go, and so far no giant technical issues. So welcome to another lecture, and welcome to your third week of class. I'm going to start off by going through some admin as usual. Assignment 1. Hopefully you all know that assignment 1 is due right before this class in a week, right? So it's 15 minutes before this class starts in 1 week is when assignment 1 is due. I want you all to do the right thing with this assignment. It's supposed to be a really powerful educational experience. It's not supposed to be something grueling. It's not supposed to be something terrible, okay? So I want it to be a good assignment for all of you, right? First of all, don't get stressed out about it. How do you do that? Well, being organized is really important, okay? So notice the deadline. The deadline, as I said, is a week away from today, like 15 minutes and backwards from one week, okay? That's the first thing. Know how it's delivered and know the deadline policy. No deadline. There is a deadline. There's no extensions, okay? There's no extensions, okay? So if you don't get it in, no big deal, because we have a policy where it can be redeemed, as you saw in our example, the COMP1110 student on Friday. So it will be redeemed, so don't stress, okay? If you're getting stuck, please ask questions on Piazza, but please do not ask private questions on Piazza. We can't answer 500 private questions about this part and that part of your assignment, and it's not fair to everyone else. Instead, this is hard, I know, but instead, what you really need to do is take the time to go and recouch your question in a way that you can ask the question without disclosing your answer. That can take a little bit of time, but it helps you think through the question. So if you're running into a problem, try and think about how you can ask that question to the class, the whole class, in a way that doesn't give away your answer, okay? The Piazza notes 67 and 69 are pinned to your Piazza feed, and they give you hints on how to ask a question. Make use of that. This is a really useful skill in life. Certainly, if you ever do open source software development, you're going to need to know this, okay? You're going to need to know this. So do that, ask the question there, and we'll do the best we possibly can to answer your questions. The best thing is, if you ask the whole class, you've got 500 brains helping you instead of just 13, all right? So ask the whole class. Obviously, don't post your answers to Piazza. That's a really bad idea. If you're stuck, particularly if you're stuck on some technical problem, like we still get a few people who have some issue with their setup, their home computer. That's okay. Okay, we really want that sorted by the end of week 1, but sometimes things happen. And if you're one of those people who's running into that sort of issue, the best way to do that is one-on-one. So go to one of the one-on-one consultations, or go to your lab. When I say go to, I mean virtually or physically. Go to your one-on-one consultation or go to your lab. That's the best way to resolve a technical issue. Some technical issues we can resolve on Piazza, but generally they're hard. If it's a hard technical problem about your computer and the way your computer's set up, it's very, very hard to resolve that on Piazza generally. It's best if you sit down with someone either over a video connection or face-to-face, right? So that's my suggestion for how you resolve those issues. When your assignment gets graded, a lot of people ask about this, it will be auto-graded, and then your tutor will look at the assignment as well, okay? So to get the marks, you need to pass the tests, and you need to satisfy whatever your tutor is going to grade you on. And the assessment regime is in the README file at the front of the assignment. You can go and look at that, okay? Remember, we do not expect everyone to finish this assignment. We do not. And we do not also want people to be spending 10, 20 hours on the assignment. If you're spending huge amounts of time on the assignment, there's something wrong, okay? So come and talk to someone, okay? That should not be happening to you. You should not be spending giant amounts of time in the assignment, okay? If, of course, you see that advanced question in the assignment, the really advanced one, about solving it, and you think this is fun, and you decide to spend your weekend on it and spend 20 hours on it, good for you, that's fine, okay? But don't do that just because you're chasing the marks, all right? Because that's not going to hurt, that's not going to help you, it'll hurt you, okay? They'll wear you out. But if you're enjoying it, by all means, spend as much time as you want on it, right? But the last questions in the assignment are not designed to be easy, and they're not designed for everyone to do, okay? So please take that to heart, and don't feel badly if it looks out of reach. That's okay. You'll get there. And remember, this is redeemable. By the end of the semester, you'll be acing the exam, and this assignment will become irrelevant to you, I'm sure. Okay? Plagiarism. I am afraid, as one of the intro computer science lecturers, I always need to give this speech, and I've said it a lot of times already, and most of you have heard me say this, and I apologize to all of you who have heard me say this before, but academic integrity is paramount in this course. How do you avoid the situation of cheating? How does cheating happen? Anyone know how cheating happens? Anyone have any insights? Yep. Yeah, if you copy someone else's work without saying it, that is cheating. But I was actually asking a slightly different, that's a great answer, but I was actually intending to ask a slightly different question. What I meant was, why do people cheat? Yep. Yeah, I think the answer is, most people, the vast majority of people are not evil people. They're not wicked people, okay? People in this class are good people, okay? So why do they cheat? Well, most people who end up cheating do it because they get stressed. They get stressed and then they make a bad choice, okay? That's why it happens. So my advice to you is try and avoid getting yourself in that situation in the first place, okay? Don't let yourself get stressed. Don't let yourself feel like the weight of the world's on your shoulders. Do remember that it's redeemable. Do remember that you've got 13 tutors out there to help you, okay? So please take this seriously. Don't let you get yourself in the situation where you've painted yourself into the corner, okay? And you make bad choices. Because I do follow these things up and the penalties are not very nice, okay? Again, this is only for a small minority that you find yourself in that situation, but please take what I said to heart. Make sure you don't find yourself in a position where you're tempted to go down that route. And remember, above all, this assignment's redeemable. It's a ridiculous risk to take, risk your whole reputation, when the assignment's redeemable anyway, okay? Finally, I want to just change subjects for a moment and talk about one other thing. Some of you, I said at the start, this course has got a fast start, and I explained to you why. It's because we need to teach you Java before we can do the interesting stuff. We're slowly moving into the more interesting stuff. The first 2 weeks was pretty low level, not very exciting. We're getting to more interesting stuff now. One thing I really wanted to do to reassure, I heard an anecdote on the weekend that nearly made me weep. It was really sad, okay? And it was about people going into computer science and pulling back from computer science because they thought it was too hard, okay? I don't want that to be anyone in my class. I don't want anyone in my class pulling back from the subject because they think it's too hard. That should not be true. You may feel overwhelmed from time to time, but you should not be feeling like it's too hard. Every person in this room got a grade that let them into ANU that means they're totally capable of getting a great mark in this assignment without killing themselves, okay? And you need to believe that. And if things aren't working out or it seems really hard, probably something's wrong. Probably I didn't explain something. Probably something's missing. Ask. Make sure you ask, okay? Please, I do not want people leaving this class because they think it's too hard. We've got a pretty good success rate in this class, so I'm pretty proud of that, but I want to maintain that, okay? And I really want to encourage everyone in this class to realize that you can do great things here, and I'm going to try and do everything I can to support that, okay? So please be encouraged. Please see the opportunity, and if you have problems, don't hesitate to ask. That was the cartoon I showed last time. Always ask if stuff's not making sense. If it's not making sense to you, it's probably not making sense to about another 100 students in the class. All right, with that, let's move on to the next unit in the class. We're now talking about nested classes, right? Can anyone remember what a class is? Either online, don't forget Leo's down the front here. If you've got something to say online, Leo's really great at voicing your questions or your comments. What is a class? What's an example of a class? Or can anyone say what a class is in their own language, in their own English? Yep.
It's kind of like a template.
Yeah, exactly. The answer was kind of like a template or a blueprint, right? It's like a blueprint or a template. Okay, you make this blueprint or template, and then you make lots and lots of instances, which we call objects, okay? So you have a template for your bike, and then you have lots of bicycles, which are instances of that type, all right? Now, today we're going to talk about a slightly squirrely, strange thing that Java does that allows you, so far you probably may have noticed, those of you who are really sharp and on the ball may have noticed that so far in this course, every time I've made a class, it's in a new file. Have you noticed that? Right? It doesn't have to be that way in Java. It actually allows you to put other classes inside classes if you want. I think if you look at the assignment in the code that was provided to you, you may find an example of that. I think maybe in the GUI class there's an example of this. Doesn't matter. You'll come across more examples later as we go through the course. But sometimes it's actually quite handy to put another class inside of another one, right? Now you can think for a moment, why would anyone want to do that? Well, there are reasons, okay? But we'll motivate it in a few moments. Now there's two different ways in which you can do this, okay? One way is what we call static, and the other way is non-static or instance, okay? And we give them different names. One is called a static nested class, and the other one, which is not static, is called an inner class, okay? Now, what's interesting about that is a static nested class is really simple. It's just the simple idea that out of convenience, you've written two classes, but decided to put the text of one class inside of the other. That's it. Simple as that. So you've written two different classes, and you've put the text of one inside of the other for convenience. Why might you do that? What human convenience? Yep.
If the text for another class is like really tiny,
Yeah, that's right. If the text for the other class is really tiny, and if you want to just sweep it away because it's a detail, right? This class needs that other class, but no one else does. It's clutter. Let's just sweep it away and put it inside of the class where it's used, okay? You can do that. And that's what that is. There's another type, which is the inner class, which is not static. And what the inner class does, just the same thing, except you don't use a static keyword. And now, every time you make one of these things, it has both classes in each object. Okay? We're going to do an example shortly, so we'll flesh it out with an example. Okay? But you can do it either statically, which is just a simple slap down of the text. It doesn't really have any significant consequence. And the other one, which is an inner class, which is just the same, except removes the keyword static, and it has this interesting dimension that one class can actually refer to elements from the other. Okay? The inner class can refer to its outer class. Okay? The inner class can refer to its outer class. And we'll show, you'll see, this will come clear in a few minutes when we go through our example. All right? Any questions on that, either online or from anyone in the room? Nope. You're all tired. I'm tired. This COVID thing's killing me. I don't know about you all, but I'm just feeling really exhausted. So, yeah, let's keep going. All right. Mini quiz time. There we go. There's a mini quiz there, and we're going to jump to some code here. So let's jump to our code. Whoops, that's not the code. I'm sorry. How embarrassing. Infinite, that's called recursion. Did anyone see that brief glimpse of recursion there? We had OBS showing OBS showing OBS. Anyway, if you go back to the lecture video, you'll catch a brief glimpse of that. That was an accident. So now we're going to write our example here. And let me see. What we're going to do is something slightly tedious. Oh, there's one piece of admin I forgot to mention. I have got a note here that I forgot about it. Two pieces of admin I forgot. Let me show you. First of all, I wanted to point out that I added some extra special bonus extra lecture material for you. If you go here to complete lectures, actually you go here to Java. All right, wow, why is this so slow? It's really weird. This lecture, our course website seems to be terribly slow when I access it from the lecture theatre. What I've done here is I've added, eventually, here we go. See that? That's an extra piece of material for that really basic stuff where I was going through, here is what a Boolean is, here is what an integer is, here is what a double is. Not very exciting, but worth looking at if you're not familiar with Java. I added in material from last year's lecture where I went and added an extra hour or 45 minutes of detail, loads of detail. These are the examples that are linkable here through the Java Waterloo visualizer. Here it is. These examples here, I'm going through them there, okay? So, for example, in the assignment, you may, there's a hint there, you may want to use charat, for example, charat or substring. Those sort of concepts, those sort of little details, a lot of those are covered in that lecture material there. Okay, so that's a bonus, super bonus extra. The other thing I did, and there's a bonus extra here for J4, there's two little bonuses here. And the other thing I did, sorry, that's the only bonus there. The other one I did was an admin one where I added, where are we? It's actually also under OO. If we go to OO here, you'll see that I added some more that I didn't finish off, the last little tiny bit. In the last lecture from Friday, I didn't finish the enum types. I added that in there. Okay, so there's a little bit extra there on the enum types. Remember, we're going to add the grades, convert a mark into a HDD credit pass. That's there. It's only about 5 minutes. It's not a lot of detail, but it's important because we need to cover enums. I mentioned them with the PowerPoint slides. I didn't give you a working example. There's a working example right there. Okay, so that's for you. The other thing I did was I spent about 15 minutes stepping through the assignment and just some stuff about how the assignment works. Some of you have already gone past the material that's there. Where is it? I posted a link. Oh, it's not there. I posted a link in the on the Piazza chat at the top of the Piazza thing. There's a link there telling you about the assignment video. It's really awesome, especially the part where I show you the plastic game, except it's off camera, unfortunately, because I didn't realize the camera was shooting high. Anyway, there is a plastic game, and for those of you who are physically in the room, there's a bunch of people here physically in the room. If you go to the Computer Science Students Association on the ground floor of the CSIT building, I've given them the plastic game. You can go there and mess around with it. It's sometimes, some people find it useful. You've also got the paper game. Don't forget the paper game, that's part of the assignment. There's also a plastic game that you can go and play with and get a better sense of what these leashes are all about and so forth. It's pretty obvious when you see it in plastic. You see the real game. Okay? Any questions about any of that? There are things I meant to go over in the admin section but forgot. Nope? All right, great. Let's get back to our code. Now what we're going to do, let's jump to the code. And what we're going to do now is we're going to create a lecture theatre. This is pretty, yep. I beg your pardon? Oh, I switched the scene. Yeah, thanks. We're jumping to code now. New Java class. And we're going to call it where are we up to? J08 dot lecture theatre. Oops, it's a comma. Lecture. All right, the reason I'm going to do this is because I'm going to show the example of a thing called a lecture theatre, which is what this room is here for those who are physically here, and I'm going to have a thing called a projector, okay, because I care about projectors because they make the lovely big picture behind me. So we're going to have a projector type and a lecture theatre type, and we're going to make them as two separate types, and then I'll show you how we can make them one inside the other, okay? So we start off with two very, very boring. Lecture theatre type, a projector type, then we will nest the projector inside the lecture theatre, right? Because there's an affinity between lecture theatres and projectors. So we'll put the projector type inside of the lecture theatre, and we'll first do it statically, and then we'll make an inner class, okay? So that's what we're going to do now. So we'll start off with something very boring, and we'll just create a most amazingly boring lecture theatre. It's going to have a name, string, name, there you go. And what else? Oh, and a projector. Okay, that's all we know about this lecture theatre. And now I need to create the projector type. Is it going to let me do that? Let me see here. Create class projector. Yep, that's exactly what I want to do. All right. So here we go. Now let's make ourselves a projector type. What are we going to put in the projector type? Okay, so now, where is the projector? Okay, so we're going to add a few little fields here. We're going to have, we're going to make things private. We're going to have private string, a model, like, you know, Panasonic or whatever, or Hitachi model. And we're going to have a Boolean, which tells us whether or not it's a HD projector, like a big widescreen, or if it's just an old one. So it's a private Boolean. Boolean HD. And then, in a little interesting twist, we're going to say which lecture theatre the projector is in. So we've got a slightly circular relationship here, right? We're going to have a lecture theatre with a projector in it, and we're going to say, oh, for that projector, it belongs in this lecture theatre, okay? So it's circular. So we say private lecture theatre and room, which room it's in, okay? Fair enough. Now we need a constructor. We'll make a constructor like that, and we'll just use the string model Boolean HD lecture theatre room like that, and we'll just initialize these variables in our constructor. This dot model equals model. This dot HD equals HD. and this dot room equals room. Very simple vanilla constructor. And then the last thing we'll do, what's the thing we're going to get in the habit of doing in this class that we've done a few times? What's a method we always add to classes to make it easy to debug? ToString, right? We often put ToString here because it allows us to have a string representation of an object. In fact, later today, I'm going to do an example where we don't do the ToString, and you'll see it looks terrible. So you'll get gobbledygook. Okay, so we're going to write a ToString method here. So it's public string ToString, like that. And then what we'll do, we'll return the model, and we'll say whether it's HD and what room it's in. Okay, so we'll say return model, model, and then a colon, and then we'll string concatenate in the model. Remember, the plus sign in a string is concatenation, gluing together two strings. Model, and then we'll put a comma and then say is, and we'll say is or is not HD. What I'm going to do here is add a little bit of fancy syntax, which is just a little bit of a trick here in Java. You don't need to do it this way, but this is a shortcut way of writing an if statement in line. Okay? I forget the proper name for it. We're writing a little if statement there. Say if it's HD, then do this is nothing. Otherwise, we'll say not is not HD, and then we'll say plus HD. Right? So what that's going to do is it'll say is, and then if the thing is HD, it'll do nothing. Otherwise, we'll put the word not in there. Okay? I could have said this. I could have said not HD, and then I could have said not, like that. Remember the exclamation mark? Exclamation mark is negation, right? So like that. Is that right? Oh well, I've still got to do this anyway. Okay, so there we are, and then we'll say what room it's in. We'll say in room plus room.name. .name. Like that. Okay, so now we've got a ToString method for our projector and our lecture theatre. We can go and add the same to our lecture theatre. What should we do for that? Let me have a look here. What do I want to do here? Yeah, we'll make a little constructor here also. Public lecture theatre. And it's going to take a name and oh, I see. What we're going to do is we're going to initialize a projector based on what the model and the whether it's HD. So when we create the lecture theatre, it'll say like Manning Clark Hall, Samsung HD, right? And so then it will create itself a room and a projector with that type. Okay, so we'll do that. We'll say string, that's the name of the room. And then we'll say string proj model, it's a model of the projector, string, Boolean, proj HD is a projector HD, and then we'll say the following. We'll say this dot name equals that name, and we'll create ourselves a projector. We'll say this dot projector. Incidentally, notice how the projector here is grayed out because we haven't used it yet. Now it's changed color as I typed that in. We'll say new projector, projector, and we'll pass it. What are we going to pass it, folks? Do anyone remember what we need to pass it? We need to pass the name, the projector model and projector HD. What was the last thing we need to pass? The lecture theatre. But what's the lecture theatre in this context? Anyone know? It's ourselves, right? We're creating a lecture theatre, and we want to tell that projector that this is the lecture theatre for that projector. How do I say this is the lecture theatre? Anyone else? Yep, up there. Yeah, I use the this keyword, right? So I say this, which means me, this object. This is the lecture theatre that this projector belongs to, okay? So I do that, and then we can write ourselves a ToString method too. We'll just say public string ToString, and we'll say return room, and then the name of the room, and then we'll say how's a projector, something like this, and then we'll get the two. When we write this, what happens is Java will say, okay, it wants to print out that projector. How do I get a string representation of that projector. If it doesn't have a toString method, it has to make one up. But if it does have a toString method, then it just calls a toString method. So whatever we put in the toString method will be what appears here. Okay, great. So now let's write ourselves a very simple class to use all this stuff here. 1 second here. There we go. Let's make ourselves a new class here which demonstrates these ideas. So far, it's incredibly simple and has nothing to do with nesting yet. We're going to do the nesting in just a moment. Okay, so we're nesting. And I'll add that to Git, and then I'll write a main method here. Like that. And then what we're going to do is we're going to say lecture theatre A, oops, A equals new lecture theatre, and we'll say MCH, and then what else? Other we'll say, I don't know, Sony or something. And then we'll say true, because it's a HD projector, right? Oh, true, not Boolean. Okay, like that. All right, so we said this lecture theatre, which is Manning Clark Hall, it's got a Sony, I don't know if it really does, but let's imagine it's a Sony. And then we're going to say it's true that it is HD, because I do know it's HD. All right, then what we're going to do is we're going to print out what we got. We'll just say sout. And here, at this point, we're using two classes, right? One for the projector and one for the lecture theatre. That's what we've got here. So we'll say two classes, and then say A. Right, now run this, and it should be very unsurprising what we get. There should be no tricks here. Oops, keep hitting the wrong button there. And we see it's building down there on the bottom of the screen. We run this, still building. And it's run. Okay, and there's what it printed. It said room MCH has the following projector. The model is a Sony, it is HD, and it's in room MCH. Okay? So this is really very simple and very nice. But what we want to do now is do static nesting. So let's do that. Now the way I'm going to do it, because we're all short on time, we're going to do a little bit of a cheat here and say we're going to copy this code here, and then we're going to paste it, and we're going to call it static nested. Like that, and do the same thing with a projector. Okay? So this is really simple duplication. What happened there? Okay, hang on. I'll check that in a minute. Let's see what's going on there. Projector static nested. Now, because in this little tiny simple example I've had, the only place the projector gets used is inside the lecture theatre, we're going to lift that projector class into the lecture theatre, right? And so what we're going to do is we're going to cut this code here, cut and paste. We'll delete the thing in a moment, and just simply slap it down here, like that. And we'll change this, where it says projector, we'll change that to static nested projector, like that. Okay. And here it's complaining because the static nested projector also needs to see a static nested lecture theatre. Okay, so what's happened here? Oh, and that has to be changed too. All right, so all I did was a very quick and dirty cut and paste and put the thing inside and renamed the things so that they were different to the other ones, just for the sake of avoiding confusion. So all we have, this code right here, that there, is basically exactly the same as the code that we saw in this separate file before. I just changed the name of it, right? And then I just changed the name every time it was referred to here. Okay, everyone got that? Very simple. Oh, I've made a mistake here. One thing I've forgotten to do, the whole point of this example was to make it a static nested class, which means I need to do that. Okay, so now it's a statically nested class. All right, everyone following me so far? Now what we're going to do is we can get rid of this one. There's nothing in there, right? If I click on it, you'll see there's nothing there. We'll just delete that. Oops, hang on, wrong button. Delete, there we go. Delete, yes. Okay, so we deleted that. And now what we'll do is go back to our example here, and we'll do the same thing now, but with a statically nested example, like this. We'll say static, our lecture theatre static nested. All right, so all I did was a whole lot of cutting and pasting there. And in the first example, we saw a projector class and a lecture theatre class. And this second example, we saw almost exactly the same thing, except I lifted that projector and put it inside of the lecture theatre. Okay, and we run the code, and what you should see is there's basically no difference, which is exactly what I told you would be true. The only thing that's happened is we've made that class just a little bit neater by popping it inside of the other one. Okay, so room MCH is a following projector. We could change this just in case you're wondering if this really is. Let's change this to some other brand, LG or whatever. Call it something else. I don't know what. I can't even remember what physical lecture theatres we have at ANU. It's been COVID so long. What have we got here? Just call it something else. MCX. Like that. And try that. And what you should see now is that this thing here is the one that got printed out. All right, now what we're going to do, okay, so any questions about that? So far, yep, question from the online?
Can you define another class inside your class, inside the class?
Sure. Good question. How many levels can you nest? You can nest arbitrarily many deep, okay? There's no particular limitation there. So we could write another one in here. Okay, so this one here is inside of this one, and we could write another little public static nested class here. Static public class. Yeah. Okay, just like that. And then we can do it like that. There's no problem with that at all. All right? At the moment, I'm not using it, which is why it's drawn in gray. There's no problem at all doing that. Great question. Now let's go back and do the whole thing all over again, but this time we're going to do it with inner classes. Can anyone remember what the differences are between static classes and inner classes? Yep. It's not static. Yeah, very good. Inner class is syntactically the same as a static class without the word static in front, but what it actually means is that every time you create one of these, it creates both things together. Okay, they're actually linked. So when I make that lecture theatre, it's got the projector inside of it, and the code from the projector can actually see the fields of the lecture theatre. Okay, so we don't need to call to it like it's a different class. It's actually inside the other class. Okay, so I can actually refer to the fields of the lecture theatre. So let's go and do that. Now I'm going to play the same trick for the sake of speed. I'm just going to go and, where are we? I'm just going to do the same thing in terms of code duplication. So this is, an example. Don't do this at home, folks. Don't copy code around like this because you end up getting things out of sync. Bad idea, bad practice. But what we're going to do for the sake of speed, we're doing it this way, nested. So that's just a direct copy of the lecture theatre code. And then we'll do the same thing here with the projector. And then we're going to cut the insides of the projector into the static one. There it is. Drop this inside the, sorry, not the static one, inside the lecture theatre nested. Hang on, what happened there? I put the suffix Java on the end of the file. That was an accident. It turns out that doesn't matter, but that was a bit weird. All right, and then I'll just get rid of that thing I was just using for the minute here. I'll just get rid of this. Delete. Yeah, delete it. Okay, so we've got this one here. Some stuff is, where are the squiggly lines here? Okay, we've got squiggly lines because I haven't made everything match up. So now I need to use this type here whenever I refer to the lecture theatre. Instead of lecture theatre, I want to refer to lecture theatre nested. And here, that should be a lecture theatre nested. And where else? And then the same thing with a projector. Instead of projector, I want to use projector nested. Up here, it should be projector nested. And down here, it should be create me a projector nested. Okay, so now that's all coherent. And we can run this and get the same effect, which looks very little different, but I'm going to show you how it actually manifests as being an inner class in just a moment. At this point, it probably looked exactly the same, except it didn't have the word static there. So now let's Okay, run this. And now you should see all three of them. They should look basically the same in terms of the way they print themselves out. And they're all very simple classes. And in two examples, we've combined them into one file. In the first of those, the static one, they're simply two different classes in one file. But this one, the nested one here, which is here, hang on, we've actually nested it. So in fact, this projector can see the enclosing class. That was one of the differences when you have an inner class. So this inner class, we can actually get rid of room altogether. We don't need this. And we can just refer directly to name. Like that. Okay? So this projector, this nested projector, well actually I've called it the wrong thing, I meant to call it inner. To make it clearer what it is, it's an inner class, right? Like that, okay? So now what you can see is this inner class actually refers to the name field, which is in its parent, in its outer class. You see this? So this refers to this, and I've also named this incorrectly. Let me just rename this, Control R. You can go here and refactor and rename things and make sure everything's coherent. I'll just say inner here. Inner, I meant to say inner. Oops, typo, try again, one more time. Rename, get rid of that T at the end there. And now we have an inner class, all right? So now let's run that. And you should see it works just the same. But because it's an inner class, it can actually access the fields of its parent. Why? Because there's a one-to-one relationship between the two types. Okay? When I create one of these lecture theatres, it's always got the projector there. The projector always only exists in the context of a specific lecture theatre. Therefore, there's only one lecture theatre name that it could possibly be, the one that it's its parent. Okay? So, and we see here it comes up like that. All right, now with that, I think we're good to move on. So let's do that. Oh, fantastic. We're on to interfaces. So can anyone, either online or in the room, remember what an interface is, or an example of an interface? Anyone? What's an English word that we use? By the way, Leo, is the stream okay? It looks kind of frozen here for me. All right. No one remembers what an interface is? Yeah, great.
Was it something like what methods could be applied to things?
Yeah.
Very big things about what they could actually make.
Yeah. The person in the room said, is it something like that says what methods could be applied to things? That's exactly right. And the English language, the English word we would use to describe that is, it's like a contract. It says anything that says it's a vehicle must have stop, start, left, right, go faster, go slower, right? Or something like that. You say that is the definition in our classroom. That's the definition of vehicle. And therefore, anything that wants to call itself a vehicle and say it has those attributes says it implements the interface of vehicle. Okay? So it's like a contract and says, yeah, I may be an elephant, but I'm also a vehicle. I can go stop, I can start, I can go left, I can go right. Okay, I can go faster and I can go slower. I'm a vehicle. I might be a fighter plane, but I'm also a vehicle. I can go left and right and stop and start and so forth, right? So anything that has those attributes is a vehicle. And you see that's very different to the concept of an inheritance hierarchy that says that an apple is a type of fruit, which is a type of plant, right? Or a dog is a type of mammal, which is a type of animal, okay? So that's an inheritance hierarchy. This has nothing to do with that. These are cross-cutting concerns. The aeroplane and the elephant and the donkey and the taxi don't have very much in common, except they're all vehicles, or they all can be vehicles, all right? And so they all might choose to implement the vehicle interface, which means for all of them, you can say stop, start, and so forth. All right? That's the concept we're addressing here. So, as it says on the slide, an interface can be thought of as a contract. It's a class which implements an interface must provide the specified functionality. So if it is an elephant, it says it's a vehicle, it needs to implement exactly, well, it can have other things as well, but it must have the things in the contract. It must have stop, start, and so forth. It might have many other methods, but it must have those ones, okay? Compared to a class, when you declare an interface, so let's imagine we're declaring the interface vehicle, right? This is not declaring a vehicle, this is declaring the contract, if you like, right? So now we're saying all vehicles must have the following. And the way we do that is we use the keyword interface, okay? So in Java we say, this is an interface. It says all vehicles will have start, stop, left, right, and so forth, okay? So you're declaring an interface. And we use the interface keyword rather than the class keyword. You can't make an instance of an interface. It doesn't make sense. That concept makes no sense. I can't say make me a vehicle, because the obvious question is, well, what kind of vehicle? And I say, oh, an elephant. Oh, an aeroplane, right? So you can make an aeroplane, you can make an elephant, but you can't just make a vehicle, right? You've got to say which vehicle, right? So it's, that's a very important idea. You can't create an instance of one. Interestingly enough, you can declare a variable to be of type, the interface type. So I can say this thing here, whose name is jet, is of type vehicle, and I could assign it a new object which happens to be an aeroplane. Or I could have a variable called vehicle, which is of type vehicle, and I could assign it an elephant, or I could subsequently assign it an airplane. I could assign it all different things. The variable name remains, the variable type remains vehicle. Okay, so you can have a type of a variable that is a contract. Okay, so you can say, we don't know what this thing is, except we do know that it implements that contract. That's what we do know. Okay, so we know that it's a vehicle, but we don't know whether it's an elephant or a horse or whatever. So it can only, interface definition can only contain constants. You can put constants in there if you want. Method signatures, remember method signatures are the things that say what methods this interface implements. And it can have nested types. You can't have the body of the method. You can't actually have the implementation of the method, but just a declaration of what the method looks like. A stop, a start, a go, or whatever it might be, turn left, turn right. Not the actual mechanics of how you turn left, how you turn right, how you stop, how you start. When I make myself an elephant, I say it implements vehicle. I use the implements keyword. So I say type elephant extends animal implements vehicle, right? And as I said earlier, you can use the interface as a type. So I can make myself a variable called vehicle, all in lowercase, that is of type cap uppercase vehicle, right? And then I could assign it an elephant, a car, a taxi, a truck. They're all vehicles, okay? I could assign that thing called vehicle, any one of those concrete things. All right, time for the quiz, and then we'll do some coding. Which one was that? We were just doing 03 interfaces, right? Okay. Now, what we're going to do in our coding is implement something very simple. We're going to implement an interface called toxic. Okay, we're going to have different creatures or different substances and say whether or not that substance is toxic. You know, is a poison toxic? Yes, it is, and so forth, right? So let's just, now what we're going to do here is when we create the class, notice I'm going to select interface here. I'm going to say create an interface, and we'll call it toxic. Right, there it is. And now I don't write a main method or anything like that because it's an interface. Remember, there's actually no implementation of any code here. And all we're going to do for our toxic interface is have a Boolean method that says, is this particular toxic thing lethal to adult humans? Okay? So you might have something toxic like, I don't know. Yep. Beg your pardon? Oh, change the scene. Thank you, Leo. Gee, it's really good I've got Leo in the room. You might, when we change, so you might have something that is toxic but not lethal. Can anyone think of something that's toxic but not lethal? Okay, you could think of, yeah. What's that? Alcohol is is toxic, but not normally immediately lethal. Whereas something like arsenic or cyanide is kind of really lethal. Likewise, you might find some spider bites, like a redback spider, won't kill any adult human, but a funnel web spider will be, right? Just for example. Okay, so we can just implement that. So we're going to write this Boolean interface, and we'll say is lethal to adult humans. Right, like that. Okay, then as we create each of these substances, we'll say whether or not that substance is toxic. Okay, not that we'll say whether it's toxic. What we'll say is, first of all, if it is a toxic substance, it will implement that interface, and then if it's actually lethal, it will return true. Otherwise, it will return false. Okay, so now let's start off by creating a class here called cyanide, which is kind of going to be easy, right? We'll say, yeah, cyanide. For those of you who don't know what cyanide is, cyanide's a nasty poison. And we'll say cyanide implements toxic like that. All right, now what's the problem, folks? There's red ink all over the thing. What's going on? Can anyone guess what's going on? Yep. I haven't fulfilled the contract. Right. So an interface is a contract. I've said this class, which is cyanide, implements this contract, which is toxic. And we just wrote the contract a moment ago and it said it's got to have a special method in there which says is lethal to adult humans. But we didn't do it. So IntelliJ is saying, hey, you haven't fulfilled the contract. So we now need to fulfill the contract. Luckily, IntelliJ is pretty helpful. So if we go up here and wait for that little light bulb, it will actually offer to do it for us. There it is. It's even given us the wrong answer. We want to say, yes, it is. Okay, everyone understand that? By saying it implements that interface, we have to write these methods. That's the contract. That's the whole point. Okay, and I didn't, so it had a squiggly red line. And then I said, please fix, and it added this method, which implements the method that we needed to implement. It generated some code for us, which is actually incorrect, which is a reminder you should always check the code that gets generated by a computer for you. Now we're going to have ourselves a redback spider. And for those of you who are new to Australia or don't live in Australia, like those online, a redback spider is a common spider here, which is quite nasty, but it won't kill you. Lots of Australian spiders will, but redback spider won't. Okay, it'll just give you a very painful bite. It might kill a child maybe, but not an adult. Okay, so it implements toxic. Again, IntelliJ says, hey, you haven't fulfilled the contract. You want to fulfill that contract, and we'll implement the method. And there we go, and it writes it, and it's actually by chance given us the correct answer this time. The answer is false for the redback spider. Okay, now what we're going to do is we're going to write ourselves a little method, a little class to demonstrate these ideas. We'll call it interfaces, like that. And we'll add it to Git. We'll do the PSVM thing, like that. And then what we'll do is we'll say, we'll declare some instances, okay? First of all, I'm going to, oops. Yes, that's the one I want. Why is it not? Okay, it needs to, okay. There it is. Oh, I put the cyanide in the wrong place. Oh my goodness. All right. Everyone notice that? I've messed stuff up here. This code is suddenly a giant mess. Okay, we need to implement this package. So where are we? We're in, I forgot what module we're in. We're in 03. 003. Okay. Folks, when I make a mistake like this, it's often worth watching how I fix it because you're probably going to make the same mistake one day. And just learning how I fix problems like this is sometimes useful. So what happened was I didn't put these things in the package. I accidentally put those ones in that package, and I put that one in that package, which is all wrong. And how did I discover the problem? I discovered the problem because it couldn't find the class it should have been able to find. And why couldn't it? Because it was in the wrong package, that's why. That's how I knew there was something amiss. Okay, let's just move these guys into here. move specified classes, refactor. Okay, there they are. If we open this up now, we'll see them in there. There they are. And this one also we want to drop into here, refactor. Okay, great. Okay, and now it can find cyanide. All right? Before it couldn't find cyanide, which is what made me realize I'd made some mistake. Okay, by the way, what's refactoring? Does anyone know what refactoring is? Refactoring is an interesting word that we use in software engineering. It means restructure the code in a coherent way. Okay, which means move this thing over to here, and everything that referred to it before now needs to be fixed up to refer to its new place. This is one of the powerful things you get with powerful IDEs like IntelliJ. They help you do this in a relatively graceful way. It actually can be rather hard to do this, particularly once you get to complex refactorings. It's basically impossible to do this without very, very smart tools that actually have compilers built into them that do fancy analysis that get this right. All right, anyway, we just did refactoring, which is a fancy way of saying renaming. And now what we're going to do is we're going to create some cyanide. We'll call it nasty equals new cyanide. And then we'll create ourselves another thing. Like that. Okay, and then we can ask questions about it. Now, one of the things I wanted to show you is that we don't need to declare these as type cyanide and type redback spider. We can just do the following. Like that. Okay? Which is, so we're declaring the variable nasty to be just toxic without defining what it is. When we create the object, it turns out it's cyanide. Likewise, we're declaring Charlotte just to be a toxic thing, and then when we create it, well, we're creating a redback spider. Now what we're going to do, just to make this a bit more interesting, we'll add ourselves another object in here, another type, another class, which is definitely not toxic. Okay, who's got a pet dog? Anyone here have a pet dog? I do. I spend a lot of time walking my dog. I've got a border collie. Okay, and I've just created a dog here. I've created a dog, but I have not said that it implements toxic, because my dog's not toxic. Dogs are not toxic, they're very friendly. All right, so, I mean, they can bite people, but they're not toxic. And then what we're gonna do is go here to interfaces, and we'll say dog spot equals new dog. Okay? So now what we've done in this little class here is something very, very unexciting, and we've created 3 different variables. Each one has been assigned an object. Now, what would happen if I wanted to create an array of these things? Say I want to create an array with those 3 objects in it. What type would the array be? At the back? Yep. You have to like scream. You're so far back. I can make a new interface. Yeah, I can make a new interface which they all implement it. That's great. Yep. What else could I do? Yep. Perfect. Why? That's a great answer, but why? The answer the person gave at the back was you could create an array of Java-lang object, and my question is why? Yeah, because Java-lang object is a bit like in English when we say thing. It's a very most general form of description that we can get. And if you have an array of Java-lang object, I can put any object into there. So that's exactly the right answer. But I could also have created an interface. As I look back into the gloom in the back of the room, I see people wearing masks. Good for you. No problem wearing a mask in my class. To be honest with you, I'm quite anxious that we're going to get shut down. I'm going to have to start lecturing from home soon. So yeah, if you want to wear a mask, please feel very free to do so in my class. All right, so what we're going to do is just what he said at the back there. We're going to create ourselves an array of object like this, like that, and we'll call them things, right? Because there's no real relationship between these 3 different things I created. A glass of poison, a spider, and a dog. They don't have very much relationship at all, right? So we're just going to call them things equals, and then what we can do is we can instantiate the array like this in Java. We can say nasty, Charlotte, spot, like that. And now we have an array of things, and what we can do is, how do we iterate through those things? Can anyone imagine how we're going to iterate through those? We can use a for loop. We can use one of those fancy for loops. We can say for object O in things, do the following. And then what we can do is, what would be nice is if we could test to see whether it's toxic or not, right? So how would I test if it's toxic or not? Anyone know how I'd test that? There's a special operator that I introduced early on that I'm not surprised you've forgotten, because it was in that huge avalanche of stuff I taught you in the first week. There's an operator in Java that helps you find out whether something is of a certain type. Yep? Oh, I didn't hear you, sorry. No, there's a special operator, instance of. I can use the instance of operator, which says, is this thing an instance of that type? And I can use it for classes and for interfaces. Okay, so let's do that. We can say, if, we can just call this T for thing, if T is an instance of, if T instance of toxic, then S out T is unpleasant. Right, like that. Else, like that. All right, and then what that's going to do is go through all the things and print them out. Anyone know what it's going to print out in terms of the name of the object when it prints out T? Yep. Yeah, it's going to print out the toString, and the default toString, seeing as we didn't go write ourselves a toString, is something unpleasant. So we'll see that in a moment. Let's have a look. And in a moment, we're going to have a quick break. Where are we? Run. There it is. So cyanide is unpleasant, redback spider is unpleasant, and dog is nice. Okay? And notice how it printed out in that strange way. If we wrote the toString method for each of those types, then it would say, let's just show you by example. Okay, like that. Except I can't type very well. It should be parentheses here, right? There we are. Now we run it, and whatever we wrote there will get printed out instead of that other horrible thing. All right? Okay, like that, because we returned this string for toString. So this thing here is the default toString, and that's our overridden one. And we often do this just to make it clear, override, just to make it clear that we have overridden the default implementation of toString. All right, that's not part of the lesson, but I just did that for fun. What else did I want to show? Oh, one last thing, and then we'll have a tiny break. What I want to show you quickly was that we now want to call the method, right? If I've got a toxic thing, I have the ability to find out if it's lethal, right? Yeah? So what would be nice in this code here if I could say this thing is lethal, or this thing's just merely unpleasant, right? How would I do that? Yep. Yep. Let's try that. We add an if here. We can do it. We can actually do it with our fancy little if statement, but for the sake of clarity, let's just add an explicit if statement here. We'll say if T dot is lethal to adult humans. Oh, IntelliJ is too smart. Stop doing that. I wanted just to do it like this, but it went and auto-completed. Let's just do that. And in a minute, we can find out what I'm talking about. I'll explain myself in a moment. All right, like that. And then else that. Now, okay, those of you who are watching closely will notice, first of all, right now there's red text there. And second of all, if you're watching carefully, IntelliJ fixed it for me faster than I could type. But I wanted to show you the problem first so you could see what was going on here rather than just see some magic from IntelliJ. Can anyone guess why that text there is in red? I mean, everything looks fine, but there is a problem with it. Yep?
Well, is lethal to adult humans is defined in the toxic phase?
Is lethal to adult humans is not defined in Java-lang object, right? And at the moment, T, as far as this piece of program knows, all it knows about T is that it is a Java-lang object, and it's trying to call is lethal to adult humans on Java-lang object, which of course doesn't have that method because we haven't changed Java-lang object. Okay? So what we now need to do is say, hey, we know this thing is implementing the toxic interface. We just checked the line above, right? See the line above? We just checked it. So although the array type is of type object, we can tell you for sure this particular object is actually implementing the toxic interface because we just checked it, right? And the way we do that in Java is by doing a typecast like this. And we say toxic T, like that. Oops. I put the parenthesis in the wrong place. Double parentheses. Is this it? Am I doing this right? There we go. Yep. Lots of parentheses. Okay, so what I'm saying is that T, I'm telling you it's actually implementing the toxic interface because I just checked the line right above there. And if it's implementing the toxic interface, then you can call this method on. It's okay. All right, now we run the code. And there we go. And we see here that the cyanide is lethal and the redback spider is unpleasant. Okay? Any questions on that? All right, let's take a little break. If you have any questions, feel free to come up and ask me. Otherwise, we'll just take a brief break now. Just a couple of minutes, because we've got quite a lot to cram through here. If you have questions about administrative stuff, you're welcome to ask me or Leo down the front here, or any questions about the course. Don't forget, for those of you who are in the room, you're always welcome to use the Microsoft Teams and join the team chat there and ask Leo questions. If you're embarrassed to ask out loud or just prefer not to, you can ask him and he can voice your question, right? Explain. Just while we're having a break, I'm just going to explain this here. This at override, that's just a little convenience thing that says, yeah, you know what? The toString method is implemented in the parent, that is Java-lang object, but I'm going to override it and put my own toString method here. And I know that that's what I'm doing, right? It's just by putting that there, you're essentially saying, yeah, I know I'm changing the behavior of my parent. I'm aware of that. So it's just acknowledging that that's what you're doing. Good question.
What's the difference between like interfaces and data types like string and char? Because they seem to be used in like a similar method, where, especially when you initialize things, where you're like, hey, we've got toxic dog, we've got string stir, we've got int x.
Good question. I'll answer it for everyone. The question was, what's the difference between an interface and an actual data type, like the data type dog or the data type string or an integer? And I think the answer to that, probably the best answer to that is that an interface is like a contract. It's an abstraction. I can't make a vehicle unless you're quite specific and tell me which vehicle. I can't just fabricate a vehicle. I can fabricate a string, but I can't fabricate a vehicle because a vehicle is an interface type. So it's like saying, you know, it's an idea, if you like. And we're going to come to another one soon where in fact, on Friday, I think, we're going to introduce the idea of an abstract type, which is a similar idea, but different idea. And again, with an abstract type, you also can't create one. Okay, if it's abstract, that means you cannot create one of these things because it's merely an idea. For example, you might say, we're going to do animal hierarchy in a minute, the kingdom, animal kingdom. But you might say that something is an animal, but you can't make, a mammal, for example, mammal. Okay, I can't create a mammal. I can create a cow. Cow is concrete, mammal is an abstraction, it's an idea. Okay, likewise with the interface. I can create a car, but I cannot create a vehicle unless you're specific about which kind of vehicle. Likewise, if you say create a mammal, like which mammal? Okay, so that's the basic idea. It's an abstract idea, not a concrete idea. Any other questions? I'm just fielding random questions while we have the break. Anyone else have a question they want to answer, they would like answered? Yep.
Can we use the two-string method in the assignment? Like, can we make two strings for the dogs?
The question was for the assignment, can you use a two-string? And the answer is, yeah, you can always use two strings. Why would you want to do that? Well, the answer is it's often easier to debug. Okay, that's the only reason why you do it. The one caveat to that is make sure you don't break tests. There may be some tests that make assumptions about that. I don't think there are, but there could be. In which case, you wouldn't want to do something like that if it broke the tests. Okay, but otherwise, for sure, writing two strings is actually quite useful, particularly with something like a location. You can print out the x and y coordinates and so forth. All right, so two string is a really useful debugging tool. At the back there, yep, you, yep.
Before we declared the nasty variable, we had declared that as not being of type toxic, but being of type cyanide or something.
Yep.
Would that still be an instance of toxic?
What's the last bit you said?
Would that still be an instance of toxic?
Yeah, so let's just do that. So the question was, here, when I first wrote this, I wrote cyanide, right? And cyanide is declared here as implementing toxic. So I could go here, right? So now what I'm doing is I'm declaring a variable here which is some random toxic thing, I don't know what it is, and I've assigned it to be equal to the cyanide, which is we called nasty, right? So this one here is of type toxic, this one here is of type cyanide, okay? And you can do that, that's just fine. So this one here is not well defined, that one's very concretely defined. And this code still works, we run this code and all still works. Last question?
Can you apply instances to individual objects rather than classes? Sorry, instances, interfaces.
Say it again, sorry?
Can you apply interfaces to individual objects?
No, not in Java. So the concept of an interface applies to the entire class. I can't say that bicycle, that elephant is a wild elephant and therefore it is not a vehicle, whereas that elephant there is a trained one and therefore it is a vehicle. I can't do that, unfortunately. What I need to do is create two different types, a type of wild elephant and tame elephant, and say the tame elephant implements vehicle and the wild elephant doesn't implement vehicle, if that's what I wanted to do. I can't just apply the implements method just to that one elephant, right? So it has to be done at the level of a class. Great question. All right, let's keep forging ahead, folks. There's so much to do. Oh, wow, Lambda expressions. One of the key ideas in object-oriented programming, which I've tried to reinforce with you all, is that objects encapsulate two things. What do they encapsulate? What are the two ideas? I'm going to put an exam question about this, guys. So, yep. Perfect. Yes, state and behavior. State and behavior, right? So the state of the bicycle thing might have been like its location right now, and the behavior might be please go faster, please turn left. So they're like verbs, and that's like a noun. That's a thing, that's where it is. So it's the state, and the behavior is change that bicycle in this way or that way. Okay? So, and they're reflected as, the state is reflected as fields of the object, the behavior is reflected as methods of the object. Okay? State and behavior, two key concepts. Now, sometimes you want to just have behavior without the state. Right? Notice we already have state without behavior in the primitive types. The primitive types don't have methods. Int, char, and so forth. They don't have methods on them, those little primitive types. So in that case, you've kind of got state without behavior. We sometimes want behavior without state, okay? Behavior without state is like, I've got a description of something, like it might be, give you a random number. So I go around the room and say, each one of you gets a random number. Okay, that's a behavior that I'm going to apply to one thing after another. Okay, that's a behavior, but it doesn't have any particular state associated with it necessarily. Okay, so well, it might, but it may not. Okay, in which case I've got behavior without any associated state. So it's not really the concept of an object isn't really applicable there. So I want to basically go through the room and apply a behavior to each student in the room, which might be, assign a random number or something like that. Okay, so in that case I've got a behavior, but I don't have state. Right now, one way to achieve this thing, and I need you just to believe me for the moment, suspend disbelief, and just believe me that the idea of having behavior without state is sometimes quite useful, okay? And you'll find examples later. One example you'll find is with JavaFX. We use it when we deal with events, which we're going to describe, I think, in the end of this week even, okay? But what we need is we want to describe behavior without the state. And how do we do that? Well, back in the earlier versions of Java, before they introduced this concept that we're discussing now, what you did is you created an object with no fields, but methods. If you had an object with methods but no fields, you've got the behavior, the methods, without the state because there's no fields. So you can do it that way. That's a kind of kludgy, not very pleasant way to do it. Lambda expressions are a more clean way to do that. Okay? And other languages have this same sort of concept. It's a way of describing a behavior. Okay, we're going to run through a very simple example in a few minutes. So from Java version 8 onwards, Lambda expressions allow code to be passed as a parameter just like data. So I can give you, so I've got a thing called update the student, and I pass it a behavior which generates a random number, and so I pass the behavior of the generate random number as the argument. Rather than passing an object as an argument, so far we've always just passed objects or primitive types. Now we're going to actually pass a method, a behavior, and that's what we call a Lambda expression. Okay, so they're particularly useful for event handling, which is what we're going to do at the end of the week, I think, when I say, for example, when this key gets pressed, do this thing. Okay, so do this thing, that's a behavior, right? So I say to the software, I say, hey, every time the key gets pressed, do this thing. So I pass it the behavior I want to have happen every time a key gets pressed. And the syntax we use is we have formal parameters which are just separated by commas. Then we have an arrow, and then we have the body, which can just be a single statement, or you can use curly braces to make a compound statement. Okay, so the example there is you've got a parameter, x, if you've just got one parameter in that example, and then you've got a statement, which is an expression with x greater than 100, which is a Boolean expression, right? Is x greater than 100? That's a Boolean expression. So that's a very, very simple lambda, which takes one parameter, x, and it produces a result, which will be a Boolean, which is true if x is greater than 100. Otherwise, you could write a compound one, which is the one on the right there, which takes, that particular example takes a single parameter, x, and it does some stuff, which is a ... You have to write the code in there, and then it returns true or false, okay? For example, for a Boolean. Yep, question. Can you say that again?
Is there any reason why there's no semicolon after 100?
No. So I think the question was, why isn't there a semicolon after 100 in that example up there? Typically there would be if we put it in context. Yep. But not necessarily, because it could be, yeah, there is a reason why there's not a semicolon, because we don't necessarily need one. Sometimes we do, sometimes we don't. If it was a declaration of a Lambda variable, like I got some variable, the thing I want to do, and I say it's assigned that statement there, then the end of the assignment statement would have a semicolon, right? But if I wanted to pass it as a parameter, I'd have a comma after it, not a semicolon. Okay, so this is an expression which may be terminated with a semicolon in an assignment example, or it may be terminated with a comma in the case where it's just a part of a list. We'll see examples in a few minutes. Okay, but that's why it's ambiguous in that case, because it could be either, depending on the context. Okay, functional interfaces. We can actually declare these functional interfaces, and again, I'm going to show you examples in a few minutes that say a certain sort of lambda will have a certain pattern to it, and the actual implementation could be different, but it's a bit like the interfaces we talked about earlier. A few minutes ago we talked about interfaces, and the first one here is an interface which is an int predicate, which allows you to say this interface here will return a boolean given an int. Right? It will return a boolean. If you give me an int, I'll give you a boolean saying true or false. This satisfies the criteria, it doesn't satisfy the criteria. I won't tell you what the criteria is just now, but there's going to be some criteria, and you give me an integer, and I'll tell you whether it satisfies that or not. So it's an integer produces a boolean. And there's one here, which could be another one here, which is the double supplier. Double supplier is one that says, I'm going to give you a double using some criteria for giving doubles. Could be a random number generator, who knows what, but something that says, I'm going to give you a double. So again, it's a behavior, and it's described in terms of what it delivers. It delivers a double. Okay, let's go to the mini quiz, and then we'll go to an example. And again, hopefully the example that I give here will help make the ideas I just said there a little bit clearer. Just waiting for my network interface over here. Piazza's gone offline for some reason. All right, let's get moving because we're running out of time here. There we are. It's back online. And publish the poll. There you go. So now what I'm going to do is create another type here, which is going to be J09, and we're going to do Lambda. Java class J09.lambda, and what I'm going to do is write a main method here, and I'm going to declare a method here which will take a lambda as an argument, okay? So, and the way I'm going to express it is as an int predicate. It's going to take an integer and an int predicate and then do something with that, okay? So we'll say static void print big, and then we'll pass an integer value, and then int predicate. There it is. Int predicate is big, or big test. Right. So this thing, you know what that is? That's just an integer value. This thing, on the other hand, it will be a lambda expression. And so this will take the lambda expression and apply it to the integer and say true or false. It's big or not, depending on this definition of big. We're going to define big ourselves in a few minutes. Okay? And then we're going to say if big test dot test value, so it's going to run the test, which should return true or false for this integer. Then we're going to say, yep, it was big. Otherwise, it's not big. All right. Now, what we can do is we define, the whole point of this is we can define, we can make our own definition of bigness, right? This is the point, is we're defining the behavior. We're using a lambda to define our own, make our own definition of what big means. Okay, so it's not hardwired. I'm going to pass you my definition. The lambda captures the definition of this behavior. And so I'll write a simple example here, and we'll say print big, like that, and then we'll say 200, say, and then we'll write a lambda expression like this. Okay, so what we've done here is we're going to pass the value 200 to this little method here, and if x, which is 200, is greater than 1,000, then it will be true. That means big number. Okay? Notice this is an example where the lambda expression is not followed by a semicolon. Okay? So let's run this, and what should happen? Well, we should run this code. We pass it 200. We pass it a special test, which is the definition of bigness, which in this case is greater than 1,000, and it should test it and say, well, no, x is not big, okay, according to that definition. We run this piece of code here, run, and we should find that it's not big. running, it's building. No, it's not big, exactly what we expect. But if we change this to 2000, we pass 2000 and give it the same test for bigness, it should say, yeah, that thing's big by this definition of bigness. We can make our own definition of bigness, obviously. That's the whole point of this, is we can capture the idea of bigness. It's an idea, it's an expression. We can capture that in a lambda and pass that to the function. Okay, and yes, it is big. All right? And then what we can do is we can also declare, turn that lambda into a variable. All right? So we can do that by declaring it to be an int predicate, big test, and then we can do some other test, like, I don't know, x is, right? So this is a different definition of bigness. Okay, so now we've got two different definitions of bigness. The first one says things are big if they're bigger than 1,000. This other one says, oh no, they're big if they're bigger than 100. Okay, and then what we can do is we can like that. And now what it should do is pass this value 200 to this test, which we, by the way, we could have written it like this. This would have been exactly the same. Okay, but I wanted to demonstrate that you can make it a variable like that. We can run this thing here, and of course this one should say, yeah, 200 really is big by this definition of bigness. Okay, so this lambda is capturing idea, and we're passing that, and it's saying, yes, it is big. Okay, and notice in this case the lambda is followed by a semicolon, right? And then we can do like that. Let's run that. And of course 10 is not big by that definition of bigness, so it should say no, it's not. Okay? Any questions about that? Online or, yep.
What if you passed it a test that didn't return a boolean?
If I passed it a test that did not return a boolean, then it wouldn't, it would be the wrong type, so you get a type error here. Okay? So if it didn't return a boolean, yeah, there'd be a type error here. So I could say, if I just did this, for example, x returns 1,000. That's a legitimate lambda, but it's not a very useful one in this context. I get an error. It says bad return type for the lambda expression. It can't be converted to a boolean. Okay? So luckily, this is one of the advantages of using a tool like IntelliJ, is it will actually explain to you what's going on. Otherwise, stuff would just crash and burn. You'd shrug your shoulders and think, oh, well, that didn't work. Why? Well, if you hover over the squiggly line, it'll tell you. And it can be quite complex sometimes. So it is very, very worthwhile, folks, to get into the practice of trying to work out when stuff isn't working. Don't just shrug your shoulders and go like, oh, man, that didn't work. But rather try and find out why it didn't, because there's usually something they're telling you why it didn't. It may be sometimes a little bit hard to decode, but it's almost always there. Did you have a question? Here it's being passed to print big, which is expecting an int predicate, which takes an integer and returns a boolean. So that's why it complained. That's how it knew that this thing was supposed to return a boolean. Okay? In this particular case, because it says, oh, well, print, you know, it wants an int predicate, which is something that has to return a boolean. And this thing, when I edited it, it didn't return a boolean, so it complained. Okay, let's move on, folks. Marching onwards. Now we're getting to another of the really big topics in Java. We're talking about inheritance. Object-oriented programs rely on inheritance. There's a lot of questions about whether inheritance is the most awesome idea or not. It's probably not an awesome idea, but it's an idea, and it's an important idea. Okay, it's an important one because lots of languages, whether you like it or not, when you go out into the real world, languages like Java and C++ and other languages depend heavily on the concept of inheritance. So in this class, you're going to learn about inheritance because it's a very important idea in computer science. So an inherited class is known as a superclass, subclass. Superclass is the other way around, right? Superclass is the one above. It's a subclass if it's inherited, or a derived class or a child class. These are kind of synonyms. People use different language in different contexts. A parent is known as a superclass, or a base class sometimes, or a parent class. Again, these are synonyms. People use different language depending on the setting. Subclasses inherit via the extends keyword. So for example, cow extends mammal, mammal extends animal, right? So it means a mammal is a type of animal. You don't have to say when you extend Java lang object. Every time we wrote one of these classes for the past week and 2 weeks of class, we could have written extends Java lang object, but we don't need to. That's kind of a waste of time. They implicitly, everything implicitly extends Java lang object. You don't write that out, right? Because everyone knows that in Java, everything extends Java lang object, so you don't have to write that out. But logically, it's kind of there silently saying, yeah, that thing you just made, that dog or whatever, extends Java lang object. And it's written on the slide there. Yeah, all classes implicitly inherit from Java lang object. Overriding and hiding methods. If you have an instance method, if it's got the same as one of the superclasses, it overrides. In fact, someone asked me that a few minutes ago about toString. So Java lang object has toString. We make our own toString. We're overriding it. So the one in the child is the one that gets used. Okay, the more specific one is the one that gets used. And that's called overriding. And we mark it with the override annotation. It's merely an annotation. It's just saying, hey, yeah, I know what I'm doing. I'm deliberately changing the behavior of my parent for a good reason. I'm making it more specific. Okay? The same name, number, and type of parameters and return type as the, if you override, it has to be exactly the same in terms of the number of parameters and the return type and the name. The type of the instance determines the method. So if I have an instance that is of type cow, then it doesn't matter how it's declared. It could be declared as animal, but it will use the method for a cow if there's an overriding in cow. Okay, it'll be whatever the concrete object is. When you call new, what was it? It'll be that type. Okay, class methods. If it's got the same signature and you have it in there and there as a class method, that's a static method. Remember static methods and instance methods. If you have a static method overriding, that's generally considered a bad idea. Okay, I gave you the example with toString where it's a good idea to do it with an instance. To do it with a class is generally considered a poor idea, a bad idea. But if you did do it, then if you call a class, then whichever class you call will be the one that you call it on will be the one that whose method gets invoked. So if I say cow dot average size or something, it'll be the cow, not the mammal method that gets implemented. It gets invoked. Polymorphism is a really interesting idea. You already saw that a few minutes ago when I did that thing with toxic, and I made toxic be of type redback spider or of type cyanide. And the same is true for inheritance. That was interfaces. Now we're talking about inheritance, and I can make a variable f of type fruit, and I could assign it an apple or I could assign it an orange. Okay, so we don't know necessarily what type f is until we see what it's assigned to, what's assigned to it. So if an apple is assigned to f, then we know f is of type apple. If an orange is assigned to f, we know f is of type orange. Okay, and that means that f is polymorphic, means that f takes different shapes. It can take on the shape of an apple, it can take on the shape of an orange. That's because we declared f to be the type that is a superclass, supertype of apple and orange. Okay? And if I call a method on either of those types, then the concrete type apple or orange will be the one that gets invoked.
Hey, Steve.
Yeah.
Back to previous slide. Is the annotation override compulsory?
It's not compulsory, but it's good practice. Someone asked if that's a compulsory to use the override. It's not compulsory, but it's good practice. Hiding fields. When a subclass uses a field that has already been used in a field in the superclass, that's hidden. You should not do it, but you can. Right? So what's an example? If I had, we haven't done an inheritance yet, but we're about to do it. But if we declared the same thing twice in the parent and the super, that's very confusing. Okay? Normally we just declare it in one, but you can do it in Java. It's just now you've got two different versions of the same field. How would you differentiate them? Can anyone guess if you did do something as crazy as that, which you should not do, as it says on the slide? If you did, how would you differentiate them? Anyone know? You'd use super and this. You'd say this dot my silly field or super dot my silly field, and that way you'd get the one that you wanted. But don't do that. That's a really bad idea. It's very confusing. The super keyword, I just mentioned it. Super keyword is an analog, if you like, to this. This means this object. Super means my parent type. Okay. So the one place. Anyone remember a place where you've seen this? You see it in constructors often. You call it on the constructor of you may call your parent's constructor, in which case you use the word super to do that. Okay, I think I gave an example really early on before I'd explained these concepts. When I use super, that's a classic example where you call super. But basically, if you want behavior from your parent and you want to be explicitly your parent, you say super. And the classic example is if you want to call a constructor of your parent. So you have part of the constructor yourself, and then you want the more general form to be done by your parent. Okay, time for the mini quiz, and then we're going to do a big coding blitz. I'm going to have to code really, really fast here. Just waiting for my network connection again, for IntelliJ to wake up. Oh, sorry, for Piazza to wake up. And then we're going to do a giant blast of of inheritance. Okay, and this is going to be in the package 04. File, new Java class. What I'm going to do is I'm going to create, first of all, I'll create one called inheritance, 004.inheritance. Okay, IntelliJ is still not replying. Sorry, not IntelliJ, I mean Piazza. There it is. I've just opened the poll. All right, and so now inheritance. So what I'm going to do is I'm going to create a whole lot of creatures, 2, 4, 6, 8 different creatures of 8 different types. And then after I've created them, we're going to draw the inheritance relationship between them. Okay? So as I'm creating them, it's going to take me a few minutes to do this. You need to think about the inheritance relationship among them. Okay, so let's get cracking. So file, new Java class. The first one will be of type albatross. Now, if you don't know what these are, you've got a few moments now to look them up on Wikipedia to find out what these creatures are. I'm going to add that one. File, new Java class. Dog. All right, add it to Git. Yep. File, new Java class. Fruit bat. Also, a time to brush up on your biology. If you're not sure what type of fruit bat is, then now's your chance. And of course, if I'm wrong, you can yell at me and tell me I've got the biology wrong. Eastern brown snake. And those of you who don't live in Canberra may not know what that is. It's very, very dangerous, and they live in Canberra, and there's lots of them. Great white shark. Add that, and we've only got 3 more to go. And of course, in Canberra, you need to have a platypus, which also complicates your inheritance hierarchy because they're really weird. And we're going to have a human, of course, in the mix. Okay. All right, great, terrific. Now what we're going to do is we're going to go to our inheritance thing here, and we're going to create instances of each of these. Albatross, Alex, right, like that. What was the next one? A dog is a spot, is called Spot. Now, I'm going to ask you in a minute to help me with inheritance hierarchy. Fruit bat, Fred, new. So I'm making all these animals. New fruit bat, there we are. Eastern brown snake, Eastern brown snake. Snake is going to be called Steph. Snake. And a great white shark has to be called Bruce. Redback spiral, Charlotte. Like that. Okay, so we're creating all these animals. Only got 2 more to go. The platypus, Perry, the platypus. Like that. And finally the human, who's going to be called Bob. Like that. All right. Now what we're going to do is we're going to like we did before, we're going to create an array of object, because these things are all different types. And if I want to put them all in one array, the only way, like the person in the back said before, is I'm going to have to create an array of Java-lang object, because there's nothing in common between these types, right? So we're going to create an array of object like that. I will say animals equals, and then I'll say Alex, spot, Fred, spot, Fred, Steph, Bruce, Charlotte, Perry, Bob. All right, like that. There we go. There's all our animals. And then what we can do is we can go through a for loop, and we can, just like we did before with the other type, we can say for animal, well, object. We don't have animal type yet. We're going to do that in a moment. A in animals, print something out. What will we do? All right, that's not very exciting, but we'll run it now. And then what we're going to do in a few now at this point is add an inheritance hierarchy. Okay, so what would be the logical inheritance hierarchy here? Anyone want to take a stab at guessing that? What's a good inheritance hierarchy for this particular thing? Anyone? What these are all of type what? Well, what would be the parent type here? At the moment, we've got Java-lang object. What can we be a bit more specific here? There's no tractors or cars here. They're all animals, right? So we can do that. And then we've got mammals, we've got reptiles, we've got a bird, we've got a monitoring. And we've got a fish, right? So we can add all those things in, and we can draw like a tree for all these different types. When I say draw a tree, in our heads we can draw a tree, right? So let's just add those in now. So there you go, hi, and this has got this horrible name, right? But we can, what we can do here is, get name, like that. That won't tell us the variable name, but that should look a bit more pretty. Is that right? No, that's not what I want. Get canonical name. Anyway, we'll fix this up later. But what I want to do now is add in this inheritance hierarchy. So we're going to add new classes here. And the first thing we'll do is add a type animal. New Java class animal. Right? Just like that. Now we're going to create a new type reptile. What do we know about the reptile in terms of its inheritance relationship? Yep. Yeah, it extends animal, so it inherits from animal. Yep, extends animal, like that. Okay, and then we can say, that's reptile. Now we can say mammal. And that extends animal as well, right? Oops, no, animal, like that. Do you spell mammal with 2 M's? Yes, you do. All right, and then what else do we want here? We want, we've got a mammal, we want a bird. Extends animal. And then we want fish. The shark is a fish, right? Like that. And then we want an arachnid, which is a spider. Arachnid, is that right? I don't know how to spell it. Arachnid, is that right, the right spelling? We'll have a go at that. And the monitoring. What does the monitoring inherit from? Anyone know? how do you spell monitoring anyway? Is it spelled with a E-N-E? I think it's like that. Is that right? You can tell me. No, apparently not. It's giving me spelling assistance here. Oh. Rename to, typo, rename to. Oh, it doesn't know. Is it A there, right? Is it? Oh, meme with an M? Like that? No? M. All right. That doesn't look right. Well, put it back how I had it, which is clearly wrong. Okay. All right. Anyway, that's not really important. What's important is what does it extend from? It extends from mammal, right? Like that. And do we have any other things that extend from? Now what we can do is we can work through to these things and say what they extend. Extends bird, right? The dog extends mammal, like that. The fruit bat extends from what? Anyone know? It's a mammal. Great white shark's a fish. The human extends a mammal. Platypus extends monitoring. And the redback spider extends arachnid. And then, oh, hang on, I missed eastern brown snake, which extends reptile. Okay, so we've now got ourselves a reasonably rich little inheritance hierarchy. I'm going to go and create a constructor for animal. What fields do we want for our animal? Let's do the same thing as we did for a person. Name, int age, and then we'll make a constructor here. Say public animal string name int age, like that. And so this dot name this dot age equals age, like that. And then we can do the following. We can say what sort it is. We can say public string toString, and we can say something about the animal. We can say return its name. And this solves a problem I was running into before about how we had that toString method on whatever it was I was running before. We can say is and then we'll say get class, get the class of the thing, so the fish or whatever it is, and we'll say get simple name, and then we'll say aged, and then the age. Okay? Now, we've got problems here, and what are the 4 related problems? And it's saying here that we need to, hang on, is it going to give us the, yep, it wants us to implement the, create the constructor, and it did it for us right away. And it's got one related problem here, there, create a constructor matching the super, one related problem. Now it says, okay, so what's going on is I hadn't implemented the constructor for each of these subtypes, and now it's saying you need to go through and implement those, and IntelliJ is helping me along the way. So now when I create the albatross, I need to pass the arguments there for the albatross. You know, Alex, and albatross has lived for a long time, so Alex is going to be relatively old. And then what other problem have we got here? Fish. We've got a problem here, and we'll say create the constructor. There we are. Now we have a constructor there, and we've got a related problem here, and we need to say the great white shark implements that as well. And then we've got a related problem here, and that's because we need to say here the Bruce, and then give Bruce an age. Okay, and where are we next? We go down here. for the mammal, and we'll say, okay, there's a problem with mammal, and we create that constructor. Now there's a whole bunch more problems because all the mammals don't have their constructors, so we're going to see what those problems are. You'll notice how I'm fixing these problems one by one. There's a problem with dog. We need to write the constructor for the dog. The whole point is each one of these types has to have the same type of constructor as its parent, but we don't need to write any code for it. We can just say, do whatever our parent did, and so we pass it to our parent, okay? And that's what IntelliJ is doing for us. And then we say spot. Sadly, dogs don't live quite as long, so spot's probably a bit younger, like that. And then, where are we? The fruit bat. Fruit bat also needs a constructor. There it is. We've got a related problem here. We're going to say Fred. I have no idea how old fruit bats get. Okay, and then we've got a related problem down here with this. We need to do the same thing for the human. Give the human a constructor. Then we've got to create Bob down here. There it is. So we created Bob. And we've got the monitoring. And we need to create the constructor for the monitoring, which matches its parent. And then we've got to create the constructor for the platypus, which matches its parent. And then finally, we've got to initialize that platypus. Here, Perry, and then give Perry an age. And then we've got a couple missing here. Where are they? We've got a problem here with the arachnid. Oh, we didn't say that it extends animal. That's why it didn't complain. As soon as we do this, it'll say there's problems. Animal. Extends animal. There we are. And now we've got to fill that in. There we are. We've got a related problem. We need to go and construct this one, write its constructor. And then it's got a related problem because we've got to go and give Charlotte her name. And then what are we left here with a snake? That's about it. So reptile, and then we're done. Oh no, there we go. So yeah, we just have to fill out this here, create a constructor matching the super. We've done that. We've got a related problem here, which is we need it for the eastern brown snake, which is extends reptile. And then we need to do this here, and we say Stev. All right. We've done an awful lot. We're nearly finished now. If I just do that, we should get all of the animals. Let's run that. And where is it running? It's still compiling it. There we go. Alex is an albatross, age 49. Spot is a dog, age 9, and so forth. Fantastic. Now what we can do is we can, how do we find out if we go and print these things? How do we do something special for one particular type? Like we want to do something special for the platypus, for example. How do we do that? Yep. Yeah, exactly. I taught it to you just about half an hour ago. Instance of. It's an operator to say if a instance of platypus, then we can do something that only platypus can do, which of course is, where's the platypus? We just add a method here. Let's just add ourselves a method, public. Here, we'll make the platypus quack. Okay, and make that the type void. And then when we go through this loop, we'll say, hang on, was this thing actually a platypus? And if it was, then we'll say a.quack. Right? And notice that IntelliJ has changed its type to be platypus because it knows that it has to be platypus if that's going to work. And then the other thing we can do here is change this to animals. Remember, we start off having an object. We can be more specific now because we know it's an array of animal because each one of these things is an animal. And then the last thing I want to do is in this class, let's run this. It should go through here, and when it hits A and says it's an instance of platypus, there we go. So Perry is a platypus, and then Perry quacks for us. Great. Now what I want to do is say which ones of these are venomous, how would I declare that something is venomous? How would I do that? Yeah, it implements the venomous interface. So which ones are venomous? Not an albatross. Eastern brown snake, yes. Implements venomous. Venomous. Oh, I haven't. Oh, I need to copy it over. Where is it? Oh, actually, I have to make the type over here. So just quickly make that type. New type. Forgive me for being a few minutes late here. Java class interface venomous. We'll add that to Git, and we can also do the same thing. We can have a Boolean is lethal to adult humans, right? And then our Eastern brown snake can implement that. Venomous, there it is. And now we have to implement that method because we've agreed that we're going to be venomous, so we have to implement that contract. So we implement that. And the answer is most certainly yes. True. Okay, Eastern brown snakes can kill you, fruit bat and so forth. What else is venomous? Many of you won't know this, but actually platypuses are venomous. Implements venomous. And then we've got to go and implement its contract. Implement methods. Is it lethal? No, it's not. It's incredibly painful, but not lethal. Same with the redback spider. Implements venomous. And there we are. Implement the method. And is it lethal? No, it's not, but it's just unpleasant. We'll go back to here, and now we can go through this loop again, just like we did before, and we can say if it's an instance of venomous, then we can say print this. If it's an instance of venomous, then so we say venomous. We can say the following. We can say then we can say will or will not, will, can, and then we say plus, and then we put a little expression here. We say venomous A dot is lethal to adult humans, like that. So if it's lethal to adult humans, then we will return the string nothing, or else we return not. Like this, not, so there's a string not. So depending on whether it's lethal to adult humans, we either return that or nothing. And then we say, kill you. All right, so what should happen now is it should go through this loop. It should check all these animals. If they're venomous, it should find out if they're lethal to adult humans. And if they are, it will say it can kill you or cannot kill you. Let's see if that works. There we are. Charlotte is a redback spider, cannot kill you. Platypus cannot kill you, but the eastern brown snake can kill you. All right, before you go, let's just do the bio. This is one of the coolest bios. John von Neumann. Anyone know who this guy is? Okay, if you don't know who he is, go to Wikipedia and look at this person. This person is one of the most incredible people of the last century. He contributed to so many fields and made so many fundamental discoveries in mathematics and computer science and computer architecture, helped develop the, on the Manhattan Project, develop the nuclear weapons and all this sort of stuff. If you've watched the great film Dr. Strangelove, Dr. Strangelove is partly modeled after him and partly after Teller. And there's some great books. If you know about game theory, he's the father of game theory as well. But he's also the father of the von Neumann architecture, which is the basic computer architecture that's on your computer today. So make sure you read up on von Neumann, one of the most incredible computer scientists ever. Not necessarily the nicest person ever, but a very, very interesting person. And have a great week, and I'll catch you on Friday.